In the last lecture, we have learned static heap allocation. Now we are going to learn stack and heap storage allocation. So first we are talking about stack. So there are a few points. So whenever a function is called, its activation record is created. And it will be pushed into stack. It will be pushed into stack because we are talking about stack. And next, whenever a function complete its execution, or we can say its activation record, is popped out of stack. So what is the meaning of that? How I am saying like that? So first let me explain. I am taking the same example as I have taken for the static storage allocation. So now I'm talking about the dynamic or runtime memory allocation. So I'm taking the same example, factorial 5, suppose I am taking, right? So for factorial 5 calculation, what is required? First we need to go to factorial 4. For factorial 4, what is required? We need to create factorial 3. We need to go to factorial 3. For factorial 3, what is required? We need to go to factorial 2. And for factorial 2, what is required? Factorial 1 is required. Right? So here, every time whenever a function is called, its activation record is created. So here, when factorial 5 is created, one activation box is created, in which what we have stored? We have stored NL as 5. Right? So, and what it is saying, whenever a function complete its execution, its activation record is popped off the stack. So when factorial 5 is created, activation box is created, and here what we stored n value as 5. Here what we stored n value is 4. Here what we stored n value is 3. Here what we stored n value as 2. Here what we stored n value as 1. Right? So this is the recursion function, and we know this is the base condition. So here we stopped and we get the 1 value, right? So from here we are taking the value 1 and here we are going, right? Once we stopped here, we have taken value 1 and we are going here. So now here we know 2 into 1 is equal to 2. Because we have this value, that's why we are able to calculate it. While we have seen in the static one, because we have not taken this, or we can say for every function activation box has not started, so our value were wrong, as we have learned in the last lecture. But in this lecture we are creating activation box for every function, so here values are there, so we will get the correct value. How? We will see here. So now it's 2. Now 2 into 3, from here it will be 6. 6 into 4 it will be 24, and 24 into 5 will be 120, right? So here in this way we are able to see that factorial 5 value is 120, right? So what we are saying, whenever a function completes its execution, its activation record is popped out of the stack. As we have completed this one, because this is the dead end, or we can say this is the base condition of the recursion. So we have stopped here, we have this value, so this is popped out. After that we reached here. Once its execution is completed, it will popped out and we reached here. When its execution is completed, then it's popped out and we reached here. And its activation or its function is completed, it popped out and we reached here. So that is the meaning of these two sentences which I have discussed. So now coming to the next point. What is next point? So the next point is, as we are able to see here, the stack storage allocation is or we can say the stack storage allocation is supported recursion. stack storage allocation is supported recursion, as you are able to see here, because we are getting the correct answer. The next one is locals are always bounded to new activation record. New activation record only. Locals are always bounded to new activation record only. Why? Because we are using or we are working on stack. So new activation record means the top of the stack. Top of the stack. Right? Because we know stack, whatever function are we either we are pushing it or popping it, we do from the top, because it based on the LIFO, last in first out, because it is open from one side only. So whatever function we are performing, we can perform from the top only. Right? Now, what is the next point? What is the next point? Yeah, once function is completed, once function is completed, its execution its activation record is popped out of stack. Popped off of stack. What is the meaning of that? It means we can't get it back after some point of time. After some point of time. Obviously, we are able to see here, as we are saying, we are performing here pop operation. Once it get completed, we need to pop out. Right? So once we popped out this thing, so because it popped out, it's not in the stack right now, so we can't it back. Right? So once it's completed, we don't have such variables to store or any function. Right? That is the thing. And one more thing, in that respect only, one more thing is also there. That is what? Suppose if we have n number of functions, as we are able to see here, and instead of n we can say 5 here, a number of function, so we can't go at n directly, right? We can't go at n directly. First we need to get n is equal to 1, then 2, then 3, and up to n. In that way only we can get it, as we are able to see here. Because in recursion, first this function is there, then for this function completion we need this one, then this one, then this one, then this one, and here only we will get the answer, and from there again we are getting the answer like this and this and that. So that is the meaning of that. If n number of functions are there, so we can't go at n directly. First we need to go to 1, then 2, then 3, and up to n. So this is all about stack. This is all about stack storage allocation. Now we are coming to the heap storage allocation. Heap storage allocation. What is that? So in that way, what we are having allocations, deallocations can be done at any time in any order. And what is next here? It is also supported recursion. Recursion is supported by it. So as we know, heap is what? Whenever we need memory from the system, and in a program and we need memory, so we can take it from the heap. So that's why we are saying that allocation and deallocation can be done at any time in any order, because if RAM is available or we have some memory location in heap, so we can provide them. And in the similar way, it is also supported recursion. So this is all about heap and stack storage allocation. In the next lecture, we are going to learn code optimization. If you like it, comment in section below, and if you want to learn something, then let me know any topic.